Welcome back to The Explainer. I am absolutely thrilled you're joining us today because we are embarking on a truly profound intellectual journey. We're going to take a hard look at the very nature of reality itself. I mean, have you ever looked around and just wondered if there's some kind of hidden architecture beneath everything we see, touch, and experience? Well, today we are unpacking a concept that has completely migrated from the fringes of sci-fi directly into the lecture halls of quantum physics and philosophy. So ask yourself, what if the laws of physics aren't actually laws at all, but code? What if the universe is less like this giant mechanical clock and way more like a massive multiplayer video game? Could the cosmos itself really be a vast computational system? Now, I know, it sounds exactly like the plot of a Hollywood blockbuster, but some of the absolute brightest minds on the planet are starting to take this question very, very seriously.
Section 1. The Simulation Idea, a New Lens for Reality.
Okay, let's dive into this. To understand how this idea transitioned from late-night dorm room speculation into a rigorous academic debate, we really need a framework that bridges technology, science, and philosophy. And that brings us to Rizwan Virk and his groundbreaking book, The Simulation Hypothesis. Now, I want to be super clear right from the jump here. Our objective in this explainer is not to definitively prove that you and I are living inside a computer. Not at all. Instead, we're going to investigate exactly why world-class physicists, computer scientists, and technologists are increasingly using the language of computation, information processing, and virtual worlds to describe our physical reality. Virk just gives us a fantastic lens to examine this massive shift. Section 2. Evolution of Virtual Worlds, from Atari to the Cosmos. To really grasp this, we first need to look at the macro level, the tangible, frankly explosive evolution of our own technology. Think about it. 40 years ago, we were at stage 0 in video game development. We had Pong. Literally just two white rectangles bouncing a square dot across a black screen. Today, we're hovering around stage 3 and moving rapidly beyond it. We have photorealistic, massively multiplayer online role-playing games where millions of people are interacting simultaneously in these incredibly rich 3D-rendered virtual worlds. The trajectory is just astonishing. We're moving toward immersive VR, augmented reality, and eventually direct brain-computer interfaces. Virk maps this entire progression all the way up to a theoretical stage 11. And this leads right into a famous observation by tech entrepreneur Elon Musk. He points out that if you assume any rate of technological improvement at all, games will eventually become indistinguishable from reality. I mean, even if the rate of progress slows down drastically, given enough time, whether that's thousands or millions of years, a technological civilization will inevitably reach a point where virtual worlds look and feel exactly like physical ones. Which brings us to this absolutely crucial definition, the simulation point. This is the exact moment in a civilization's development when they possess the raw computing power to create hyper-realistic ancestor simulations. Think of it as a civilization running a highly detailed historical simulation of their own forebears. If a civilization's computing power ever allows them to simulate conscious beings with independent storylines, a really massive question arises. What happens after that point? Section 3. The Bostrom question. The logic of the matrix. So, to figure out what happens after the simulation point, we turn to the cold, hard logic of Oxford philosopher Nick Bostrom, who formalized this whole debate back in 2003 with his famous simulation argument. Bostrom proposed a trilemma, basically 3 distinct possibilities regarding advanced civilizations. Option 1, all civilizations go extinct before ever reaching the simulation point. Option 2, advanced civilizations do reach that point, but they simply choose not to run ancestor simulations, maybe for ethical reasons, or honestly, maybe they're just not interested. And option 3, any civilization that does reach the simulation point will likely run many, many simulations. Now, remember, this is a philosophical argument about probability, not a scientific certainty. But if options 1 and 2 are false, we are left entirely with option 3. And here is the staggering statistical logic of that third option. If a post-human civilization runs thousands or even millions of ancestor simulations, then the number of simulated worlds is going to vastly outnumber the one single base reality. Therefore, the number of simulated beings will vastly outnumber the actual biological beings. Statistically speaking, if you are a conscious entity experiencing a reality right now, the sheer math suggests you are almost certainly one of the billions of simulated beings rather than the incredibly rare biological original. It's literally just a numbers game. Section 4. Rendering engine of reality,
the quantum mysteries. Now, what's really interesting about this slide is how we zoom from that macro level right down to the micro.
We are going to look at the actual literal physics of our universe to see if it behaves like a simulation. Let's just compare two models here. On the left, we have the classical Newtonian physical world. This is the stuff we're all taught in grade school, right? Space is continuous, objects are solid, and reality is immutable. It exists exactly as it is, whether you're looking at it or not. But over on the right, we have the computational simulated world. Space is made of quantized discrete pixels, reality is conditional, and the environment is only rendered when a player is actively observing it. So, which model does modern science say our universe actually resembles? Surprisingly, it's the right side. To understand why that is, we need to quickly define conditional rendering. Imagine if a video game tried to render every single leaf, every rock, every drop of water in an entire digital universe, all at exactly the same time. The computer would crash instantly, right? There's just not enough memory. So game developers use an optimization technique. The game engine only draws, or renders, the specific parts of the scene that the player is currently looking at. The rest of the world, it just exists as latent code in the background. So here is the absolute kicker. Quantum physics tells us our universe does the exact same thing. Quantum indeterminacy dictates that subatomic particles exist in this weird blur of probability and don't actually take on fixed definitive properties until the very moment they are observed. We call this the observer effect. It acts exactly like conditional rendering in a video game engine. Furthermore, physics tells us that space isn't actually continuous. There's a minimum observable unit of distance called the Planck length. You literally can't zoom in any further. It acts exactly like a 3D pixel. And what about the absolute speed limit of the universe, the speed of light? Well, it functions identically to the maximum processing clock speed of a computer system. When you look closely, the universe appears to be heavily optimized. Section 5. Universe made of information? The source code. This brings us to a profound paradigm shift in modern physics, the search for the source code. Are we really replacing physical matter with digital information as the absolute foundation of the universe? Legendary physicist John Wheeler summarized this evolution beautifully. He noted that first we thought everything was made of physical particles. Then quantum mechanics came along and taught us, well, actually, everything is made of interacting energy fields. But finally, towards the very end of his career, Wheeler concluded that at its deepest level, everything is information. He famously coined the phrase "it" from bit. The physical "it" derives its very existence from digital bits of information. Top physicists today are increasingly viewing the universe not as a collection of physical matter, but as a vast information processing quantum computer. Pioneers of information theory like Alan Kay and Claude Shannon recognize something vital here. In normal science, you're given a world, and your job is to figure out the rules. But in computer science, you give the computer the rules, and it creates the world. When physicists look at subatomic particles today, they see mostly empty space. What they find at the core isn't solid stuff, they find mathematical data points. Some string theorists have even discovered equations hidden in the fabric of space-time that are identical to computer error-correcting codes. I mean, these are the exact same codes our web browsers use to transmit data without corruption. It's wild. Section 6. If reality is a simulation, the meta implications. And this brilliantly illustrates the philosophical side of things. Let's zoom all the way out to the meta level for a second. If we entertain this hypothesis, what are the mystical and philosophical implications for us as human beings? Virk neutrally points out some truly fascinating overlaps between modern computation and ancient Eastern mystical traditions. Think about the Sanskrit concept of Maya, the idea that the physical world is just a temporary, highly convincing illusion. Or think about karma and reincarnation. In a video game, you play multiple lives, trying to learn the mechanics, complete your quests, and level up. If you fail, your avatar dies, but the player outside the game learns and tries again. It raises some pretty wild questions about who is actually playing. Are we all player characters, or are some people around us artificial NPCs? Does our consciousness actually exist outside the simulation, only to be downloaded into biological avatars right at birth? It's kind of amazing how the simulation framework acts as this incredibly surprising bridge. For centuries, science and religion have been totally at odds, right? One describes a strict material universe, and the other describes an illusory proving ground for the soul. Yet information theory and virtual reality concepts provide a brand new vocabulary where both models suddenly seem to align. The ancient cosmology of an illusory world guided by strict, unseen laws perfectly maps onto the modern technological concept of an algorithmic virtual reality. Ultimately, what you should take away from this explainer is that the simulation hypothesis isn't really just about computers, microchips, or video games. Not at all. Those are simply the modern metaphors we happen to be using today. This is really about humanity's oldest, deepest, and most enduring search for truth. Whether the universe is made of string theory, divine consciousness, binary code, or something entirely beyond human imagination, the mystery of our existence remains as profound and beautiful as ever. I want to leave you with one final mind-expanding thought. If reality were indeed a perfectly rendered simulation, how would you even know? And honestly, more importantly, would it change the way you live your life? Would it change how you treat others or how you experience love and joy? This is your Cosmic Librarian signing off for The Explainer. I invite you to keep questioning the world around you. Please subscribe, enable those notifications, and join us for our next deep dive into the hidden nature of reality. Keep learning, keep focusing, and I will see you next time.